Right now, there are over 8 billion humans on this planet. We've built cities, split the atom, sent machines to Mars. It feels like we were always destined to be here. But there was a moment, not that long ago in evolutionary terms, when the entire human species came within a hair's breadth of disappearing completely. Not a metaphor, not an exaggeration. A real documented population crash so severe that some scientists believe as few as a few thousand people were left alive on Earth. And almost everyone alive today, all 8 billion of us, descends from that tiny surviving group. So, what happened? And how close did we actually come to not existing at all? The story starts about 74,000 years ago on the island of Sumatra in what's now Indonesia. Beneath a lake called Toba sat a supervolcano, one of the largest ever known to exist on Earth. And on that day, it erupted. Not like a normal volcano, this was one of the biggest explosions in the last 25 million years. Geologists call it a VEI 8, the highest classification that exists, a category so extreme only a handful of eruptions in Earth's entire history qualify. To put it in perspective, Mount St. Helens in 1980 was a VEI 5. Toba was thousands of times more powerful. It ejected an estimated 2,800 cubic kilometers of material into the sky, enough to bury an area the size of the continental United States under a meter of ash. Ash fell as far away as India and the Arabian Sea. Sediment cores pulled from the ocean floor thousands of kilometers from Sumatra still contain a clear, unmistakable layer of Toba ash, a permanent scar left across the planet in a matter of days. And that was just the beginning, because the real danger wasn't the eruption itself, it was what came after. Supervolcanic eruptions on this scale don't just destroy the local area. They punch sulfur dioxide and fine ash so high into the atmosphere that it spreads globally, blocking sunlight for years. This is called a volcanic winter, and Toba's was one of the worst the planet has ever experienced. Some ice core studies suggest global temperatures dropped by 3 to 5 degrees Celsius in the years following the eruption. Some estimates go even further, suggesting localized drops of up to 10 degrees in certain regions. That might not sound like much, but a few degrees is the difference between a normal growing season and total agricultural collapse. Except there was no agriculture yet. There was only what could be hunted, gathered, and found. Forests that had taken centuries to grow began dying off. Rain patterns shifted. Some regions, especially in Eastern Africa, where a large portion of the human population lived at the time, may have swung into a period of extreme drought. Lakes shrank. Plant life that animals depended on collapsed, and when the plants and animals a human population depends on start disappearing, the humans depending on them start disappearing too. This is where the genetic evidence comes in, and it's honestly the most unsettling part of the whole story. In the 1990s, geneticists studying human DNA noticed something strange. Compared to almost every other species on Earth, humans have remarkably low genetic diversity. Chimpanzees, who number in the low hundreds of thousands today, have more genetic variation among themselves than the entire human species does across 8 billion people. That's a massive red flag. Low genetic diversity is usually a sign that a population went through a bottleneck, a period where the number of breeding individuals dropped so low that most genetic variation was simply lost, never to return. In 1998, a geneticist named Stanley Ambrose proposed a theory that connected the two. He argued that the Toba eruption triggered a population bottleneck so severe that the entire human species may have been reduced to somewhere between 3,000 and 10,000 breeding individuals. Some more extreme versions of the theory put the number as low as a few hundred. To be clear, this figure is still debated today, and newer archaeological evidence has complicated the picture. But the genetic signature of some kind of bottleneck around this general period is real, and it's one of the strangest things we know about our own species' history. Think about what that actually means. At certain points in the fossil and genetic record, our entire species may have existed in numbers smaller than a single university campus today. Every person you've ever met, every civilization ever built, every language, every war, every piece of art, all of it potentially traces back to a surviving population that could have fit inside a small town. So, what did it actually look like on the ground? Picture small, scattered bands of humans, maybe 25 to 50 people each, spread thin across a landscape that had turned hostile almost overnight. Ash in the water, ash in the air. Animals dying or migrating away. Food sources that had been reliable for generations suddenly gone. Groups that had once been able to trade, share knowledge, and interbreed with neighboring bands may have found themselves completely isolated, cut off by the collapse of the ecosystems connecting them. Isolation like that is exactly the kind of pressure that shrinks a population fast. Fewer resources, fewer successful births, fewer people to pass anything on to, and yet, some of them made it. One of the most remarkable pieces of evidence for this comes from a site called Pinnacle Point, on the southern coast of South Africa. Archaeologists have found evidence that small groups of humans survived by shifting almost entirely to the coastline, harvesting shellfish, an incredibly stable and predictable food source that doesn't depend on unpredictable rainfall or fragile plant life. Layers of shell middens, essentially ancient trash heaps made almost entirely of discarded shellfish shells, show up at coastal sites dating to right around this period. While the interior of the continent may have been collapsing, small refuge populations along the coast appear to have quietly kept going, eating what the ocean reliably provided. This detail matters more than it might seem. It suggests survival during this period wasn't about being the strongest or most advanced group. It was about being adaptable enough to find a stable food source when everything else failed, and being willing to completely change how you lived to do it. Not every human population made it through, though. And this is where the Toba theory connects to something even bigger, the disappearance of our closest relatives. Some researchers have proposed that Toba's aftermath contributed to pressure on other hominin populations across Asia and Europe as well, groups that were already living on thin margins in harsh environments. While the science here is far less certain than the core bottleneck evidence, it fits a broader pattern we've seen again and again. Climate shocks hit small, isolated populations the hardest, and around this general period, several human lineages were already struggling. Now, it's important to say that not every scientist agrees Toba caused the bottleneck. Some archaeological sites, particularly in India, show stone tool traditions continuing with little disruption immediately above and below the ash layer, suggesting some human groups weathered the eruption with less damage than the bottleneck theory implies. The debate is still active, but even the skeptics agree on this much. Something happened to human genetic diversity around this general window of time, and whatever it was severe enough to leave a mark that's still detectable in your DNA today, in every single person's DNA today. So, what actually got us through it? The honest answer is probably a combination of things. Small, isolated pockets of humans who found stable resources, like the shellfish-eating groups on the South African coast, social networks and shared knowledge that let some groups adapt faster than others. And, frankly, luck. Being in the right place, near the right coastline, with the right food source, at exactly the wrong moment in Earth's history. But here's the part that should actually stop you for a second. Every single human alive today, every person you've ever loved, every person you've ever disagreed with, every stranger you'll pass on the street tomorrow, all of it traces back through an unbroken chain of survival, stretching through one of the tightest bottlenecks a species has ever squeezed through. Somewhere on a coastline in Africa, in the ash-choked aftermath of the largest volcanic eruption in 25 million years, a small group of people who had no idea what a volcano even was, who couldn't have understood why the sky had gone dark or why the rain had stopped, simply kept finding food, kept having children, kept surviving one day at a time without any idea that the entire future of their species rested on it. We weren't destined to be here. We very nearly weren't. And the only reason any of this exists, the cities, the art, the language you're reading this in right now, is because a few thousand people, huddled on a coastline 74,000 years ago, refused to stop.